Okay, so if I'll just move on then, because I think the checking code is stay safe. I'll put it in the chat. All right, so just going over an overview of what this this presentation will go over is the OWASP, which stands for the Open Web Application Security Project. And what this basically is, it's the top 10 referenced in the context of web security. And so it's like the list of the 10 most common application vulnerabilities. Obviously, we don't have time to discuss all of it. So I chose two specifically that I want to go into. And the first one is injection, which is number 1. And then the second one is cross-site scripting, or XSS for short, which is number 7. And this is based on the 2017 version. Right, and then I'm going to go into a demonstration with DVWA, which stands for Damn Vulnerable Web Application. And it's an environment in which you kind of like play around with, because it's made to be very vulnerable. And so you can test out specific vulnerabilities. And lastly, we'll go into like the tools. So the two tools that I chose would be Burp Suite and OWASP ZAP, which stands for Z Attack Proxy. And so this one is I think a lot of people have heard of Burp Suite. ZAP is not as popular, but it's I really like it. So I thought it would be interesting to go over this one. Okay, so OWASP, right, stands for Open Web Application Security Project, right? There's 3 important things to understand about OWASP. One, it's a global nonprofit organization, right? So this means that they are here not to make money. Their purpose is to help the web become a more secure place, and basically to focus on improving the overall security of software. They do provide like tools, documentation, and other like educational materials, right, to individuals and organizations. And overall, like, you are improving the security posture of the organization or your company, right? The second thing to bring up about it is that they're technology agnostic. What this means is that they don't promote or exclusively provide any guidance for like one technology stack. This means that they cover, let's say, PHP as equally as they cover like Java or ASP.NET, right? Something like that. So it's in this way you can talk about like all the concepts, right, for any web technology stack, and you can appeal to a wider audience because it's not exclusively to one technology. And then the last one is their security community is extremely large. Like, I would recommend you to go and take a look at it. We're talking about over like 100 tools. They do have like coding rule sets, standards, documentations, right? And then basically places where you can chat with other developers. And so OWASP really relies on, people like you, enthusiasts or like developers who are actually willing to devote time and expertise to build these resources. Okay, so this chart, I thought it was pretty interesting, right? It's a comparison between 2013 and 2017. OWASP, the top 10 list is always updated every 3 to 4 years. Technically, I haven't seen online where it's like a 2021 version yet, but I have seen predictions that people have made for like what they believe the top 10 will be. So currently, we're just going to use 2017 because that's like the only officially released one, or the latest official released one. And so you can kind of see how like the landscape changes. You'll see the A1, like the injections, didn't really change. It still remains like top 1. You'll see like A4, the insecure direct object references, and A7, missing function level access control, have merged to represent A5 in the 2017 version, which is the broken access control. And so you kind of see like a shift. And then you'll see, for example, like CSRF, which 2013 was number 8, actually like is no longer top 10. So it's it gives you a feel for like what's happening and then what's being prioritized over others. Okay, so the first one on our list, right, we're going to look at the number 1 risk, which they rate as injection. And so, like I mentioned, right, number 1 risk also in 2014 and then 2017, and then predictions say that 2021 will also be injection. And so let's talk about what exactly is injection. The definition is here, right? But I'm not going to read off the definition, obviously. So let's break it down. So the flaw that injection attacks do is basically it's improper input or output validation, right? And the attacker can be basically anyone. It can be someone who sends data to the system. It can be internal users, external users, administrators, and this is in a company setting, right? So if you think about anyone who can take control of like the SQL and inject untrusted input into the SQL query is basically an injection, right? So that was a specific one, SQL. It could be any type of database. I say SQL because like SQL is a really popular one. And then the impact, right? It can result in unauthorized access, data exfiltration, data corruption, right? All of that. In worst case, you can have like a full system compromise. And so let's go ahead and take a look at this matrix. And it's a pretty visual representation, right? It has color coded so you can kind of tell whether or not it's really severe or not as severe. So this is the matrix of the attack vector, security weakness, and technical impacts. And as you can see here, the exploitability of a SQL injection attack is extremely easy. There are automated tools out there that allow you to basically copy and paste the URL in, and then the tool just goes ahead and extracts the data from the system. And it can be that simple. Like you can have someone that doesn't really understand the concept and you can still utilize like online tools to do that. And so the prevalence is common. So it's not as bad. So it's no longer like red, it's like yellow. And this is like one of the things that puts it up in the #1 spot because it's so common. And then if you combine it with the fact that the detectability is average, you can obviously tell it's not a blatantly easy risk to find, but it's not exactly really hard either. So it does take some probing of the system, but it's not extremely, extremely hard, right? And so the impact is severe. So if you think about it, for example, a specific type of injection attack would be a SQL injection attack. And this can lead to like the utter compromise of your entire database, the backend database, right? It means that the information in your database could be exposed publicly. It can also mean that the attacker can modify or destroy data within the database, right? Because a lot of applications actually rely on the backend database. So this is like a list of injection attacks. Obviously, it's a curated list. I didn't put every single type of injection attack out there. These are just like the more common ones per se. So for example, SQL and NoSQL, right? Those are just the different types of databases. So you can kind of group them together, right? If your project is vulnerable, if your web application is vulnerable, the user can extract data so from information such as email addresses, user or system data, and then password credentials, right? And this is basically information you don't want exposed to the public. And then moving on, so like I'm just picking out a few, right? Operating system injection. Basically, the attacker can issue different system commands, right? And then this can thwart the security measures that are in place. And then like the last one, LDAP injection is a fairly common one, I would say. It's called Lightweight Directory Access Protocol, and this protocol is used to access and maintain information services via the TCP/IP protocol. And what happens is if attackers can like use this as a exposure point, it could potentially extract valuable data or like change the entire access rights. So I thought this visual would be kind of nice to kind of understand how a SQL injection would, or an injection itself would, how it would occur. So for example, right, your application prevents a form to the attacker, right? And then the attacker sends an attack string, which could be a SQL query in the form of data. And then what happens is that usually mitigation techniques are not in place. So like, for example, if input validation was in place, this would not be possible because special characters like single quotes can't be processed. But without this input validation in place, anyone can send manipulated strings or queries to the backend, right? And then what happens is the application forwards it to the attack string to the database in a SQL query. And then finally, like the database runs that query, right? And then it gets the results back to the application, and then the application sends it to the attacker. And so that's kind of like the flow of how injection attacks work. And so with mitigation techniques, you could use, I would say, safe Application programming interfaces could be one. You could use allow or block lists, right? Obviously allow lists, right? Everything that you allow, and then block everything that you don't allow. And so it's recommended to use allow list instead of block, because there's no way you know everything that's dangerous. So it's better to have a list of what you can allow, and then everything else that's not allowed is just default blocked, right? So here are some real company injection attacks. I don't want to news report and then tell you all of the company breaches, but for example, I thought an interesting one would be the 2019 Canva one. If you don't already know, Canva is a popular graphic design startup. And so in May 2019, what happened was around, let's see, I think it was 140 million user accounts, somewhere around that. The information that was stolen was basically emails, usernames, encrypted passwords. And then I believe the company said that they used bcrypt, which is actually considered to be one of the most secure algorithms. But kind of lo and behold, right, in January 2020, the company was aware that as many as 4 million accounts were decrypted, right? And the hackers, if you want to search it up, they're under the pseudonym Gnostic players. So I thought that was a pretty interesting one. Other ones is the 2017 Equifax breach. That one was a pretty large one. And then the 2011 Sony PlayStation, which is pretty not as recent, but it's still out there. So these are just real company injection attacks to give you kind of a feel of like real information that was compromised because of this vulnerability. So this is a specific type of injection attack, right? SQL injection or SQLi. It's one of the big ones that pops up a lot. And so I do want to focus on this one. It's one of the biggest risks because of its prevalence, right? SQL databases are the most common databases that are out there. And so what happens for the SQL injection attack is that it modifies the query. And then what happens is that it performs an action in the database that is not originally intended to. And so let's go ahead and kind of give a high level overview of SQL injection again. So what happens here? So if you look at the green area, it says trusted and untrusted, right? So now we're differentiating between what is our trusted data, what's our untrusted data, right? So now we have a URL, right? It says www.mysite.com, and then it has the parameter ID of 1. So basically what's happening is it's hitting a resource called user, and it's passing a query string that's named ID with a value of 1, right? This probably translates to the below SQL statement of select asterisk, which is select all from users where the ID is equal to 1. In plain English, it translates to there's a table called users, and the statement is simply saying, okay, get me an ID where the number is 1. So with this, we have two different classes of information, right? Trusted, it's the green area. It's we own that domain, we own the resource, the user resource. And so we've configured it to accept a query string named ID. And likewise, down at the data level, we've written a SQL statement that asks to select all the columns from the user table when a particular ID is passed to it, right? So this is our trusted data. We know that we can accept this part. Then what happens is there's the untrusted part. So if you look at the parameters, this is what I would classify as untrusted, the 1. Right, this is where the bad stuff ultimately get in, because attackers can manipulate it into whatever they want to, and they can make it a vulnerable system, and then the system would do things that it was never intended or designed to do. And so that's really important to differentiate between what part of your data is trusted, what part is untrusted, right? So let's give you an example of retrieving hidden data, right? If we change the URL, right, of our original one from the previous slide so that it appends with an Boolean or right, 1 equals 1, what happens here? So all the attacker is doing here is it's appending a little condition at the end, right? So in the URL, they're saying, okay, 1 equals 1, right? That's passing it directly to the database as if it was entered into the URL, right? And remember, this can be as simple as changing the characters in the browser address bar, and then you can actually have a manipulated query string. And so if this condition, for example, 1 equals 1 is passed to the database, right, the entire logic of your SQL query or your SQL statement is going to fundamentally change, right? And since 1 = 1 is always going to evaluate to true, what happens is that it dumps like everything, it dumps more information than it was supposed to. So it's basically going to pull a single, it's no longer just going to like have like where ID = 1, right? Where ID = 1 would return you like, for example, 1 row of data, right? But now because you did 1 = 1 and you appended that additional part, what happens is that it's going to pull every single record in the system, right? And now the attacker has like what you can say they have large volumes of credit card details or your passwords or something gets extracted from the system. Oh yeah, the checking code is stay safe, PLS. Okay, so moving on with union, right? I thought this would be like an extra slide that I wanted to add for union. So basically union, what it does is it's combining 2 select statements, right? For example, right, if you use this, you can just append more stuff, right? And for example, like the first one, select asterisk, which is select all from users where ID is equal to 1. And then you're going to union select the username and the password from the users table, right? And then you'll see these 2 kind of dashes at the end that that represents a hashtag or like a hashtag per se, but it's like a comment, right, in SQL. And so that way everything else is commented after it. So you should put the a form of a comment. Okay, so there's just another example on the bottom. Okay, so now I'm going to do a demonstration for like the damn vulnerable web application. I did something different this time for this recorded. I actually pre-recorded my demos. So okay, so now that I've talked about SQL injection, we're going to do a demo with DVWA. So if you've ever heard of it before, it stands for Damn Vulnerable Web Application, and it's run on PHP and MySQL, and its goal is just to aid security professionals or students alike to kind of test out different web application vulnerabilities on an environment. So I'm just going to show you what it looks like online when you're so to install it first, right, you would actually go to this GitHub and then you would go ahead and download this. You can either clone it or you can install it directly through the command line. And then for DVWA to work, you need a LAMP stack. So a LAMP stack in this case would be Linux, Apache, MySQL, and PHP. And so I already pre-installed all the applications and I already have DVWA running. So just for like a brief introduction, you can literally Google DVWA installation and then it gives you kind of a step-by-step, and then you can go through it and download it onto your virtual machine. So the first thing that I want to do, since I haven't powered it up yet, what I want to do is I'm going to restart Apache, and I'm also going to restart MySQL. So okay, so now that I've restarted both, right? When you go to your local host, so 127.0.0.1, DVWA, and then the login page, you'll get this login page, and then I'll go ahead and log in. So when you log in, you should see this screen. It says, welcome to Damn Vulnerable Web Application. And like I told you, it's a vulnerable application. And what you do first is over here, the DVWA security, there are low, medium, high, and impossible. So you can go ahead and choose the one that you want. Obviously, if you do impossible, it's going to be harder and harder to kind of find vulnerabilities. And that's kind of the challenge here. So we're just going to start with low just as a demonstration. And over here, there are different types of vulnerabilities that you can test out in your web application. The one that we're going to test out is SQL injection.
You'll notice here that there's like a blind injection. That's just basically like SQL injection, but it's harder per se, I guess, because the HTTP response back doesn't reflect like the SQL query or any database or detail errors. So it's harder to kind of, I guess, catch or break. So we're just going to start with SQL injection. And then on the screen here, you'll see kind of like a user ID. We're going to demonstrate a basic injection first, where we're going to do a valid injection. So we should do 1, right? So what happens when we do user ID 1? Well, when we put 1, the SQL query that is kind of run is just select maybe first name, surname from users where ID equals 1, right? So that's kind of in the back end. That's what the SQL query would look like. And so on the screen, we get the first name admin and the surname admin. And then if you notice up here in the hyperlink, right, you'll notice that the SQL ID is 1. So what happens if we go ahead and change that to like 3, right? What would happen? Well, obviously, it's now select first name, surname from users where ID equals 3, right? So this in this case, it'll be hack and then me, right? So now let's try a demonstration where it's always true, right? So we'll do this, and then we'll use an OR statement, and we'll say 0 equals 0, right? Because that equals always true. Oops, sorry. Right, so this is always true. So what do you notice about it when it's always true? It means it return all the records that are true. In this case, the single quote just forces the database to consider any characters that follow after it as a string and not as SQL code. And so in this case, we get all the users that are true. So admin, Gordon Brown, hack me, Pablo Picasso, Bob Smith. So that's, for example, if you did like ID 1, ID 2, ID 3, ID 4, ID 5, right? So there's a total of 5 user IDs on this in this database. So now the next step, right? We need to go ahead to try and identify what kind of database is actually running in the backend, right? If we want to construct queries that are able to extract the information that we want. And this is very important because if we don't know what the database exists behind our web application, we're not able to exploit the SQL injection vulnerability properly. So a lot of the times, like web application technologies like use, like for example, Java, ASP.NET, or PHP, based on that technology, you'll kind of get a feel, like, that, for example, PHP applications tend to run on MySQL, or like Java will run on Oracle. So you can kind of find a correlation there. And so the basic idea here when we want to find the database is to produce an error message. So how do we do that? Remember the single quote, right, that I used earlier? If you notice this, you have an error in your SQL syntax, check the manual that corresponds to your Maria database server. So this is MariaDB. So with the single quote, right, what happened is the query in the backend generated select something, right, from something where user ID equals and then quotation mark. And so that's an error, and so it'll cause a syntax error. And so you notice how there is a banner flag or a default error message. This is a kind of a high-risk vulnerability because error messages will contain relevant information that hackers can use, and so you don't want that. Keep in mind that right now I'm in like the security of low, so maybe that's why there's like basically no mitigation technique or sanitizing in place. So right now we want to find the database version, right? So notice if I do union select and then I select version, right? Because I say I want the version. What happened here? Okay, it said the use select statements have different number of columns. So basically what happened is that the 2 select statements, right, in this case, right, let me go back. So the select statements for version, it doesn't have the same column name as the other table, right? So union, when you do union select something and something, you need to have both of the tables matching column. So the way to fix this is usually you would just go ahead and do select null and version. And then this way you can see that what happened here was it generated 10.3.24 MariaDB2, which is the version. So why are we using null, right? So the reason why we use null is that in select queries, the data types in the columns have to be compatible, like between the original and the injected query. And null is able to convert to any commonly used data type. And so you don't have to specify it. So it kind of maximizes the chance that your injection will succeed. And so that's why we're using null. So just like for another example, right? Let's say I connect this with union select, and then I'm going to do null and user instead of version. So let's take a look at this. So what happened here? It generated, this is our user, right? Admin at localhost. So now we're going to do, so admin localhost, I guess I can briefly explain. It's just the database user that's executed behind the scene in this PHP code. And so we're just going to do one more. I want to show you displaying all the tables in the information schema. And so what the information schema table is it's a database that stores information about all the other databases that, in this case, MariaDB or MySQL server maintains. And so what we want to do is we want to do the quote, and then we say, let's say, and go 0, union, select, null, table, name from information schema. Okay, and then dot tables, that's the syntax or the form for the information schema. And so what you notice here is I said 1 and 1 equals 0, right? So 1 equals 0 is always going to be false, right? So if I have a false here, it's going to be false. So all the things it returns literally everything. So even those that are true and those that are false. And so from this schema table, you can see there's users, guest book. In select queries, the data types in the columns have to be compatible, like between the original and the injected query. And null is able to convert to any. So admin localhost, I guess I want to do is we want to do the quote, and then we say, let's say, and go 0, union, select, null, table, name from information schema. Okay, and then dot tables, that's the syntax or the form for the information schema. And so what you notice here is I said 1 and 1 equals 0, right? So 1 equals 0 is always going to be false, right? So if I have a false here, it's going to be false. So all the things that are, it returns literally everything. So even those that are true and those that are false. And so from this schema table, you can see there's users, guest book. These are all the different tables inside your database. And so this is really useful and as a starting point. And then from here, you can branch out and find other relevant information. For instance, let's say I notice that I have on the bottom, I have a users, right? A users table. So, okay. So as a first guess, what I would think is, okay, users, what would be in users table, right? Usually, once you start dealing with databases, you'll realize that certain tables have certain columns. So in this case, I know there's like a password in users. So what I'll do is I'm going to go ahead and use the same syntax of 1 equals 0. Oh, I'm going to use 1 equals 0. And then I'm going to union it, and then I'm going to select the password from the users. Oh, sorry. Let me just fix this. to, oh, whoops, I'm sorry. I meant union select, and then I want to say select, let's see, I want to select null, right? Because I need two select statements, and then from users. Okay, so this way you'll see all the users, right? And then you'll see all the passwords, right? So these are password hashes that are contained in the backend database. And so this is a very big vulnerability, as you can see, right? Because like these hashes, even though hashes are supposed to be irrevertible, what happens is if you run them through like rainbow tables or you like a hash, like a crack hash, like online, you can totally crack it. So this is just a basic introduction to the demo for SQL injection. And I would recommend you go ahead to install DVWA and kind of play around in this environment just to see how to do it.
Okay, so I tried doing the recording, but I guess for some of you guys it was blurry because on my screen it's like 1080 the resolution, but I guess it's through like Zoom's screen sharing. The video is not as ideal. Okay, so next time I won't do that. But for now, I didn't power up my virtual machine, so it's going to take some time. So I'm just going to keep it with the recorded demos, and then I'm pretty sure because I'm recording it from my end, it's pretty clear on my side. So we'll just see how it goes. Yeah, I'm so sorry. Like I didn't think Zoom because I tried it and actually got like a pretty good like quality video. Yeah, it works on my, see that's the problem. See that I tried, okay. Yeah, I tried doing the demo with, so I pre-recorded the demo so that I wouldn't have problems in the demo, but I guess showing it was a problem. Oh well. Well, I'll just, is it to the point where you can't see anything though, or is it like dealable, I guess? Oh well. Okay. Then moving on, I guess I'll just talk about the cross-site scripting. Oh, you can read anything. Okay, so if you don't mind, I'll just do it on my laptop. Then I'll just do a live version or a live demo, but you're gonna have to bear with me because I need to turn on my virtual machine after this part. So I'll just show a live demo afterwards then. Okay, I could do that. I could do that too. Because like I'll check the recording after this and then check the quality because like from my side it's pretty good. So maybe if based on how they recorded it, I'll kind of see the quality. But if not for now, I could do a live version if you all want and you couldn't read anything at all on the screen. So yeah. Okay. So I guess just moving on then. This is number 7 on the 2017 OWASP top 10 list, which is cross-site scripting or XSS. And now we're going to talk a little bit about it. So the definition is on the screen, right? But I'm just going to talk about how like XSS is actually one of the most prevalent web vulnerabilities out there. So because it's one of the most common web attack methodologies, and it can allow malicious actors basically to run scripts in the context of the user browser to steal confidential information, and then you can pose actions on behalf of the user, or you can deny the availability in it to a user. So breaking it down, right? The flaw, what's the flaw? It's the improper input-output validation, just like injection, right? The attacker is anyone who can send malicious code, right? A browser script to the end user who can then like run the script unwittingly, right? Or can, as a whole, can inject the malicious code to a web page. And the impact, right, of this type of vulnerability is that can result in unauthorized access. You could steal cookies, you could steal session tokens, or you can have the entire defacement of the web application, right? And then mitigation is there are anti-cross-site scripting libraries that strip the scripts from the input sequence. So you can have like a script tag. And so with this kind of mitigation in place, there's also like input validation, AKA data validation, making sure that what is being inputted is like being processed, unnecessary or special characters are being stripped. So again, with the overview, if you guys have a recollection of the one previously I showed you for the injection, it's like swapped, right? So the red is inside and then the yellow is outside compared to the injection where it was the opposite. And so with here, right, you can see that with SQL injection, right, the attacker can actually get access to a heap of data in the system directly, but it's not, cross-site scripting is not like as, there's certainly a lot of damage, but it's not as like in the same class as like SQL injection or like injection in general. And that's why injection is 1 and then cross-site scripting is like 7. So like in terms of like security weaknesses, it's definitely very widespread. The other thing, it's very, very easy to find. And so with these two factors combined, it means it's a very, very common for attackers to kind of take a look at a website, check if it's vulnerable to cross-site scripting, and then, you know, input like a script tag or something to run like cross-site scripting, right? And so in terms of technical impact, it's moderate. So this is kind of like an overview of cross-site scripting. And then going into like the types of XSS, right? There's 3 types. There's stored, also known as persistent. There's reflected, also known as non-persistent, and there's DOM-based or document object model-based. So reflected, I'm going to talk about reflected first, because reflected is actually the most common type of XSS. And this is where the attack is delivered and executed via like a single request and response. So it's reflected back to your browser, right? That's what's different with stored. Stored is considered the most dangerous type because it's when the payload is like permanently stored in your backend database, right? And then it's served to like the other users when you go on a web browser. So it's not just targeting like one user, right? It's anyone who visits like that website that has a stored cross-site scripting vulnerability there. And then DOM-based, I'm not going to focus on this one as much, but it's basically, instead of the web server, it's executed on a DOM environment, right? And so it's in the victim's browser and it's used by the original client-side script. And then obviously what happens is that the client side or the code would run in a quote unquote unexpected manner and then kind of steal your information. So this is an example or scenario of reflected XSS, right? So first, the user gets the URL with an XSS payload and they click on this link. And the way they click on it is like social engineering, right? Most common way would be phishing emails. So you kind of manipulate like the person's psychological response. You get them to click on that specific link, and then it redirects them to like a target website, right? And so now this website receives the request with the XSS payload or with XSS in it, and it processes the request. And right, so if this attack is successful, then what happens is that the XSS payload is reflected back to the user on the web user's browser. And so this means that the data in the URL or like the malicious data is now in the HTML response that the website reflects or returns back to you as the user. So now this XSS is in the user's browser, and that's why it's reflected XSS, right? And so, for example, right, with cross-site scripting, you can access cookies for the user's browsers. And bottom line, if an attacker can get a user to load like the script on their web browser, then that script has the ability to access what cookies and then send it to like an attacker. And then that would be very easy to do, especially if you use JavaScript. And you can simply use it to take like a cookie and then request it back to the attacker's website, right? And so this is what's called reflected XSS. Again, I like the flow chart. I think it's like a simplified version of like how it flows. So most important thing is that, right, these two attacker identifies a web page vulnerability, right? The web page itself has to be vulnerable to cross-site scripting. And then you send it to the web page and then it's reflected back, right, to the system. And then the system is quote unquote compromised now. Okay, so with stored XSS, it's a little different. So now with stored XSS, right, the attacker is able to embed it into the database of that website, right? And so there's multiple ways to do this. You can exploit a SQL injection risk like we talked about before, or you can literally have the XSS persist in the database with also SQL injection, but also combined with something else. So if it's loaded into like the website, right, and then it appears in the response to the user, then we have like the same situation as the first scenario, where a malicious script appears in the browser and it gets like access to things that's not supposed to, like cookies, and then it gets exfiltrated to the attacker. But now, right, for every user that visits the website, the malicious code is activated, right? So before with reflected, it's like targeting one like individual. With stored, it's whoever visits that web application that has a stored XSS in their backend database, right? Whoever visits that website will now like have that malicious code activated in their browser. And so that's how like stored XSS is illustrated. So if you look at this flow chart, right, the first two is the same, right? Obviously, the attacker identifies the web page vulnerability and then injects a malicious string, right? And now it's up to different victims, right? It's random. It's not like targeted towards anybody. Anyone who visits that web page, now that script will run in the browser. And then obviously your system is now compromised, right? And so that's just kind of like the flow, or a simplified flow version. So understanding XSS, right? I like separating it into trusted and untrusted, right? We talked about how to differentiate between these two types of data values, right? What do we trust? We trust the domain, we trust the resource being hit, and likewise, we trust part of the output, right? So imagine in your website, you hard coded like into the application, like for example, you searched for, and then you did like strong XSS, right? With the strong tags, right? Part of what we see here is actually untrusted, which is the XSS part, right? It's the query string value that's being provided. And attackers can basically manipulate it and then add anything else that they want, right? For example, you can change it to document.cookie instead of this simple like string, right? Like for example, on the bottom, you're alerting the document.cookie, right? And now what happens? Every time JavaScript is run, there's going to open up an alert box, and then it's going to share that cookie in the browser and then send it off to the attacker, or if you are the attacker, send it off to you, right? So this in and of itself, right? This itself, like just the alert, is not malicious, but it is proof of XSS risk. It only becomes malicious when you start sending that cookie somewhere. But if you're just reflecting it like alert document.cookie, that's just like a test to prove that your web application is vulnerable to XSS. So I have the demo again. Should I just go ahead and show the video, because I haven't powered up my virtual machine, and I don't think it's that long, so I could, oh, it doesn't exist. Okay, you know. Okay, so I'm going to go ahead and actually power my virtual machine on then. So I use I have both VirtualBox and VMware installed. Some people prefer one over the other. I actually like VirtualBox better. So I'll use VirtualBox, and then let me start my account. Okay. So I'm in my virtual machine, right? Now I'm just going to have to start off, because if you saw the previous video, I know it was blurry, but if you did see the previous video, what I did was So I have a web browser. So what I did was, right, I service MySQL restart and then also service Apache 2 restart. So these two I already installed like locally on my system. And so I just need to make sure it's up and running. And then with it, when it's run, what I would do is I would navigate to localhost, which is 127.0.0.0.1, right? And then I believe it was the DVWA login page. Oh, sorry, let me just turn off my proxy. So with this, you get the login screen, right? If I remember my credentials, oh, it's not the right one. Okay, so now you're in the DVWA environment. You can play around with it. I just want to make sure that I'm set to low. Okay, I don't want to do impossible. You can do impossible to challenge yourself. The one I'm going to demonstrate is cross-site scripting stored. And let me just reset my database because I actually played around, because with store, you're going to have to reset it every time you want to try it. Okay, so I reset it, right? So let's do a basic cross-site scripting attack, right? This is to test that it's vulnerable to cross-site scripting with like the script tag. And so let's say test, right? And then I start with the script tag, and then I alert, let's say I alert, this is a cross-site scripting test. And then I end it with the script tag, right? So I click signs the guestbook, and what happens is you get a pop-up box that says this is a cross-site scripting test. And so you know, right, because the JavaScript alert is now displayed, you know that this can be easily modified to capture cookie session info or like do a mend in the middle attack, right? And so another one I want to illustrate to you is called the iframe exploit. So what an iframe is basically, it's like a box or a text box, or like it can be a text box on the screen that can store like videos. It can store like an entire website. And so adversaries like to use this for like social engineering tools toolkit, which is set to create like cloned fake websites. So for example, if I do script, I do the iframe, and then the source is going to be, let's say I do HTTP google.com. I have a feeling this is going to be not found for now, but it's like an illustration of the quote unquote website. So I'll just put an iframe, and then I'm going to sign the guest book, and it should, okay, yeah. So it says it can't open it for now, but you'll see how like in this iframe, right, you have like the URL or like the redirect to that URL. The last one I want to demonstrate is the stored cookie. And so this is also a basic one, just like you were alerting the string. Instead, now you're going to alert document.cookie, right? And what happens is that it will return on your screen like the PHP session, right? So this is your session ID, right? So the attacker could easily modify this cross-site scripting script to send it to a remote location where you as like an attacker is sitting, right? And so instead of just like the simple display box, just think of how if this was like a bank website, right? And every time you log in, your cookie info gets sent like somewhere else, like remotely, you can imagine like how big like this vulnerability is. And so that's kind of like a demonstration for cross-site scripting. And let me go back to the page. Okay, so now I'm going to go into the tools. And so with the tools, right, the two that I wanted to demonstrate is OWASP ZAP and Burp Suite. So OWASP ZAP stands for Z Attack Proxy, and then Burp Suite, I'm pretty sure a lot of you have already heard it because it's like the most commonly used one or the popular one for security professionals, right, to assess the security of your web application. And so they're both free. But Burp Suite obviously has like the pro version and like the community version. With the pro version, you also get a scanner, so it's like pretty cool. And so while Burp Suite is mostly used like as a proxy tool to like intercept, rather than like an application security scanner, OWASP is actually used for a lot of scanning. So like, for example, if you wanted to do like a risk assessment on a web application, it's it would be ideal to use OWASP ZAP, because what happens is it gives you like a bunch, it literally assesses your application, and then it gives you back like high, medium, low vulnerabilities or risks that they found through testing it through their tools. And so those are the two tools that I wanted to demonstrate. Should I try the video again?
Yeah, I'm going to do a demonstration onto
Because this one's
I introduced OWASP, ZAP, Proxy, ZAP, and Burpsuite. So I just kind of wanted to introduce these tools specifically because Burpsuite is like the go-to for like indexes. It's pretty popular. And then I was actually recently introduced to OWASP ZAP and I use it. So I thought it would be nice to give an introduction on it.
And so I just want to talk about, it's important to set up a legal target first, right? So by law, you're only permitted to either pen test or assess web applications that you either own or you have permission to test. And by permission, I mean, it's like, for example, if you have like a third party vendor and you're risk assessing them, right? You should have like a written contract or something stating that they allow you to pen test their website, right? Because what happens is when you pen test it or you scan it, a lot of times if you do an active scan, you might accidentally break something in their web application, and that's not cool. And so by law, you only permitted to assess those. So if you want to practice these tools, right, it's good to have an environment in which you know that it's already vulnerable and that you can go ahead and play around with it. And even if you break something, it's okay. Right. And so we actually have that. So what we have is OWASP broken web application. And so I would go ahead and just install it. You can search up, right, OWASP broken web application projects, and then go ahead and install the latest version, right? And so with BWA, you have a lot of web application or broken web applications that are all in one place. And it's installed by simply loading the ISO file into a hypervisor and then firing it up. Right. And so let's walk through this a little bit and I'll show you what I mean. Okay, so I used VMware. Okay, you'll notice I also have VirtualBox installed, but I used VMware to install the broken web app. And then I already have it installed. I clicked open virtual machine. And then what happens is that it is already powered up. It's right here, right? And you'll notice that when you power it up, you'll get an IP address from which you can connect to, which is 192.168.10.128 in this case. And so I'm going to open up my virtual machine or my Kali VirtualBox, and then I'm going to navigate to, right, 192.168.10.128. So it's connecting to that virtual machine, right? And then you'll see this OWASP BWA, which is the broken web applications. And notice here, these are your training applications, right? So for instance, we introduced DVWA already. And then the one that we're going to use is BWAPP. These are both module-based training tools, and they focus primarily on the OWASP top 10. And so they're good starting points for training on tools such as Burp Suite and OWASP ZAP. And so before we actually get into the tool, right, we talked about proxies, right? And so I'm going to show you how to set it up. And so by proxy, a proxy by definition, right, is to give you as a person authority or power to act on behalf of another or as a substitute for another. And what I mean by this is when you open your favorite web browser, let's say this is your favorite web browser, right? Firefox, right? And you navigate to your favorite website, let's say google.com or example.com, right? So that page, right, you'll travel through port 80 or 443, depending on whether you establish an HTTP or an HTTPS connection. And so this connection channel, that's the port, that's the connection channel or communication channel. And so now that you have a website request, right, for google.com, leaving your computer, heading out towards the internet to the web server. That's where your application resides. And then it receives the request, and then the server itself will respond back with a response, right? Through that same exact port, whether it be 80 or 443. And so as a pen tester or as a student that's interested in, testing out these tools, you need to find a way to put yourself in the middle of that communication channel, right? And so that's where programs like OWASP and Burp Suite come in. You want to be in the middle so that you can capture all that traffic flowing over your network interface, right? And so you need to set up a port, you need to set up your browser, and you need to say, feed all that traffic through that port instead of the one that you're using earlier. So in this case, like setting up port 8080 as your proxy, it will flow through 8080 instead. And so that way you can capture all the traffic that's being flowed into your tool. And so I'll show you how to do this through the web browser first. So you need to set it up on the side of your browser. And what you do is you'll find it in your settings. You can go ahead and just search up proxy. This is your network settings, right? So you can go ahead and click on settings, communication, connection settings, and then you can set up a manual proxy configuration. Over here, I already put it 127.0.0.1 and then port 8080. And then you can go ahead and click OK. And now you set up on the side of your browser, you set up the proxy, but I'm not going to do that because I already have I make it easier for myself. So I have a plugin installed, which is called Foxy Proxy. And what Foxy Proxy does is, as you can see on the screen, to your right, it's easy to toggle on and off. You don't have to go into the settings and set it all up, right? So you can go ahead and set up options. You can add something, right? Let's say it's test. And you can go ahead and set up your proxy 127.0.0.1 and then port 8080 and go ahead and save it. So when you save it, you'll see test pop up over here and then you can toggle it. But I already have web app that's exactly the same. So I'm just going to cancel it and leave it out. And notice how currently it says web, right? Because I already toggled. If I turn it off, it's off. If I turn web, it's web. So I have this. And so that's just how to set up your proxy. And so when you open up Burp Suite, by default, it's already installed, pre-installed on Kali. So it's OWASP. That's why Kali is so cool, right? And that's why there was like a previous workshop on Kali on like different pen testing tools that you could use. So it's like the go-to for pen testers, like in your toolkit. And so you'll see, so you'll see this community edition, right? So you want to click on temporary project and you want to click on next. You're going to use the burp defaults, or that's what we're going to use. And we're just going to start. So with the community edition, it's actually powerful in and of itself, but it just doesn't have a lot of features that you would use for like scanning or spidering. Because Burp Scanner is not part of the community edition, it's part of the pro edition. And so with the scanner, you'll have like, it'll be able to tell you vulnerabilities, it'll be able to tell you issues or advisory panels. When you click on, for example, target and you click on sitemap, you'll notice how there's only like request and response. It's just like the raw HTML that's going to be outputted. But like with a pro, you could have a scanner telling you, oh, X content header is missing or something like that. So even though it's not as powerful, it's still powerful by itself and still usable. So we're going to use the community edition because I don't have the pro edition, right? So what I'm going to demonstrate side by side is how it feeds or gets the traffic. So let's say proxy, right? You also need to make sure you set up your proxy through the same port on your tool. So for Burp Suite, it's 127.0.0.1 and also port 8080. Same thing as the web browser, right? So if you click on intercept, right? And then you'll notice here, right? Proxy service started on this port. It caught that. So I'm going to go to target, proxy and then intercept. Notice how my intercept is currently on. What that means is, let's say I want to go to DBWA, right? And then I go advanced, accept the risk, right? Notice how it's still loading. It's buffering. It's not giving me the response back from the server. The reason why is because my Burp Suite program, right, is sitting in the middle, right? I've turned on intercept. So now I stopped the communication channel and I intercepted that packet, right? And so what I intercepted was this. So if I go ahead and forward it, right, now I can see this. So I just want to log out and then I'm going to forward it and forward it again. So now I'm back to the login screen, right? I want to capture my login credentials. And so I turned on intercept and I enter my credentials. I click login, right? It's going to buffer again. And then it's going to get a packet, right? And then I notice here that I see username admin and password admin. So in plain text, it caught it caught the user credentials. I forward it again. And so now I'm on DVWA, right? And so if you look at HTTP history, right? If you look at your login page, this is one parameter. So this one, there are parameters, admin and password here. And so in plain text, it caught it, right? If you also look at the JavaScript page here, or DVWA, you notice how it renders an HTML or HTML, a raw HTML for you. So this is basically the same thing as if you were to click here and you click page source, right? It gives you the HTML, the raw HTML of it. And so you can capture a lot of information here. If you look at target and you want to take a look at here. And so one thing about this I want to bring up or it's an important note, is that a lot of modern websites nowadays, right, rarely is like the sole work of one company. And so a lot of this is like a lot of pieces and parts make up and work seamlessly to integrate into the web application. And this could be like scripts, audio, video, code, databases, right? And what I mean by this is, for example, let's say you create a web application, right? It's not just going to be like text, right? You're going to embed YouTube videos or hyperlinks to other IP addresses or other domains, right? And so when that happens, you notice a tool such as Burp Suite or OWASP will pick it up. So instead of like 192.168.10.128, if you have a YouTube video there, right, it'll go to the YouTube video's IP address. And that sometimes that's not what you want when you're scanning it, right? Because you want to stay what's called in scope. And so to do this, you right click it and you can add to scope and just say yes, enable scope, right? So now you notice how there's an in scope and then there's an exclude out of scope. So in scope are the IP addresses that are in there. So even if there's a video embedded that's linking you to another IP address, right? It's not going to go there because it knows in scope you're supposed to stay within the bounds, right? If you exclude it from scope, obviously it won't scan it, right? So let me just go ahead and remove this. So this is the sitemap. So you can go ahead and click on it. It'll render the request and the response just as if you were in the proxy and you wanted to look at your HTTP history. So now I'm going to demonstrate with BWAPP, right? So BWAPP looks like this. And sorry, I forgot to turn off my intercept. So forward it, and I'm gonna turn it off. Okay, so when you log into BWAPP, right, you'll get this page. And so what BWAPP is, it's a buggy web application that's extremely vulnerable to, or an extremely vulnerable web application that's designed specifically for security testing purposes. And so when you log in, you'll kind of see on your top right-hand corner, you can choose your bug. So there's like a lot of different vulnerabilities that you can do, right? There's man in the middle, denial of service. The one that we're going to demonstrate, because it's what we went over, is the reflected XSS with cross-site scripting. So the reflected one, but the post. And then you click hack, right? And so this is the reflected post, right? You can input a first name and you can input a last name. So let's just try it first, right? So what happens if I just did Bob and I did A? It says welcome Bob A, right? And then if you look at your HTTP history, your post, right? What do you notice here? You notice how in the packet, it's called Bob and then last name is A. So this is the parameter, right? But then post, this is a post request is because if you look at the URL itself does not show the parameters. So it does not show the first name and the last name. If it was a GET request, you could see the parameters like the ones in the packet. This would be inside the URL, right? But it's not. So this is a post. So it's implemented a post request. And so now that we've tried this, right, we're going to use to see how Burp Suite will factor into this. So let's turn back the intercept and I'm going to go Bob and then A again, right? So this time it's not here yet, right? You'll notice how it stopped it, right? So now it's Bob and A, but since I'm in the middle, I can change it, right? I can go ahead and I can put a script tag to test for cross-site scripting, right? So I'm alerting cross-site scripting. And then I close the script tag, right? And then I go ahead and forward it. So what I did was I changed, right? I changed the input because I was in the middle and I was able to do that. And so now I get an alert box that says cross-site scripting, right? And so same thing, if I want to see the document cookies, right? So I say Bob A and then the intercept is still on. So I go ahead and manipulate it, right? I change it to script, right? An alert, and I'm alerting the document cookie. And then I end the script tag and then I forward it. Okay, so now, right, I get back my session ID, right? I get the cookies, right? And so this is just an example of utilizing Burp Suite to intercept or to capture whatever network is being, or like network data that's being flowed back and forth, right? And so that's an example of you using it. So now that I have this, I'm going to go here, and now I'm going to show you OWASP ZAP, right? So ZAP stands for Z attack proxy, and just like Burp Suite, it is an attack proxy that you need a proxy set up. And so let me just close this, and I'm going to open OWASP ZAP. Okay, so ZAP looks like this. Okay, so I'm going to see this, and then I do not want to persist. Okay, so OWASP ZAP looks like this, right? It's an attack proxy, just like Burp Suite, and it's used mainly for pen testing applications, right? It has automated features, as you look over here, an automated scan, right? Or you could manually go through the scan. But scanners are noisy. They tend to be very noisy. And so as pen testers, you want to miss it. And automatic scan tools itself, they miss logic flaws. So it's only for like, if you wanted like a really quick scan and you kind of wanted to see an overview of maybe basic a starting point, and then from there you can branch into whatever you want to do. So ZAP is a web Java-based application, and so if you want to use this, it's cross-platform, so you can use it in Windows, you can use it in Linux, but as long as you need a Java JRE installed, by default, obviously, the great thing about Kali is that it's already pre-installed, right? And so what I want to show you is that over here, you'll notice there is different modes of attacks, right? And so if you hover it over, it tells you, right? With a standard mode, right? This allows you to do anything on the site, basically. Attack mode takes it a step further. Attack mode will allow you to actively scan any site in scope as it's discovered. On the opposite side of the spectrum is safe mode, right? Safe mode, this potentially shuts off any harmful tools inside of ZAP. And then protected mode, which I like to use, and it's the default as you enter ZAP. It allows you to perform actions on the site as scope. And so over here, you'll notice your tree window, right? And so this is where it starts off with like sites, right? And this is where all your sites, your scripts, everything that you kind of access, or it picks up the traffic that it picks up while your proxy is turned on. And this is what happens. You'll notice the context feature right here. So context feature is like the in scope, out of scope that we talked about in Burp Suite. And so same idea, when your sites populate, you can right click on the site, which I'll show you later, and you can put it into the context. And so with the bullseye here, it means if it's on, that means that's the in scope. And so it'll only spider or scan things inside that IP address or with that IP address, right? And over here, so you also have your request and response, same thing, same tags. Another thing that I want to show you. Okay, so now I'm going to actually show you side by side. So let's say I go here. Okay, so notice how the sites, right, it loaded, right? It got get DVWA, right? So just like Burp Suite, it picks up on the traffic. And so by So you'll notice here, right, if you click on alerts, right, it tells you some of the alerts or the vulnerabilities. This is why I like ZAP, because even with like the free version, there's a lot of information. So for example, it tells you vulnerabilities. In this case, right, it tells you the X-frame options header is not set, right? So it's not included in the HTTP response. So it picks up stuff that are vulnerabilities or risk of that web application. So if you look over here, right, what I talked about for the default context and putting it in scope, you can right click it, right? And you can either exclude from context or you can include in the context. So if I include it into the default context, right? Said okay. You'll notice here there's a bullseye. So this is in scope. If you want to take it out of scope, you can exclude it from scope. Okay. So now the bullseye's option.
so since we're running short on time, I'm just gonna skip over this one. I'll just give a brief introduction for this video. I'll post it later, but this video was basically an extra step further for those who are interested in Zap, because I really like using Zap. I personally use it for my internship. And so for this, like, it shows you or it takes you through how to spider and like run automated scans with OWASP Zap. So I'll post the video later, but for now, because we are running short on time, this is like last. And then so I just wanted to show you guys. Okay, so the last one is like the resources, right? So for those of you who are more interested in like or learn visually, you guys can click on Hacksplaining. And what Hacksplaining does, it takes you through to learn about like the vulnerabilities. I really recommend taking a look at it, especially since they have really cute like photos and stuff. So it is not just like paragraphs or like videos. So it takes you and you can go step by step on like how the vulnerability works. And so this is a great website to learn, especially if you're starting out. And then other websites or databases I would recommend is CWE and CVE. So CWE stands for Common Weakness Enumeration, and then CVE stands for Common Vulnerability and Exposure. These are really great. The difference between the two is that CWE, okay, is the types of software weaknesses rather than specific instances of vulnerability. So CVE are like, for example, if there's like an Adobe like breach or something, or Adobe, there's something wrong with that vulnerability within a specific product, that would be CVE. And then CWE is like, for example, cross-site scripting is CWE 79. And then SQL injection is CWE 89. So take a look at those databases. Really recommend it. And they're really good resources. And then obviously I would recommend the OWASP community. If you have time to like dabble in like whatever tools they offer, or like whatever conversations they have, or like you can actually contribute to the community too if you are interested in being like a developer for this. So those are just like resources I would recommend. But other than that, thank you for like attending today's workshop. And this is like the end of today's workshop. All right.